Hey guys, it's Off1 here, and today we're going to be solving course schedule. In this problem, we're given a variable called num courses, and all this tells us is the number of courses we have to take. We're also given an array of prerequisites. So the way the prerequisites array works is they give us a pair A and B, and all this tells us is that to take course A, we must take course B first. So for example here, we have the pair 0, 1. All this tells us is that to take course 0, you must take course 1 first. And at the end, they want us to return true if we can finish all the courses, and otherwise we return false. So let's think about this for a second. In what scenario would we return false? Well, if we can't complete the courses, then we return false obviously, but how do we get that? The only way to get that is if we have, let's edit this example here, let's say we have another prerequisite, and it's 0, 1. Well, this prerequisite here tells us that we must take course 0 before we can take course 1, but this one here tells us that we have to take course 1 before we take course 0. So if we draw this as a graph, it'll look like this, where 0 points to 1 as a prerequisite, and 1 points to 0 as a prerequisite. And as you can see, we're stuck in a loop here, and we'll never be able to complete any courses. And then at this point is where we return false. So when coming up with a solution for this, we can think about it as a cycle detection problem, because this is the only time we're going to return false. And if we don't find any infinite cycles like this, then we just return true. Before going any further, I want to say that if you don't understand depth first search, then I recommend watching my previous video, because in that video I go over extensive detail on how it works. And I'll link that in the description below. So from here on out, I'm going to assume you understand depth first search, because you need to know that to understand the next part. So the first thing we have to do is actually create this graph here. The way I created this graph is by looking at the course and seeing what the prerequisites were for it from this prerequisite array. So for example, let's say we have 0 here. Well, the only prerequisite is going to be 1. So we're going to have an array with just 1. The reason we're using an array is because we might have, let's say we have another prerequisite here that's 0, 2. Well, then we would need to store both prerequisites there. But for this example, we're just doing the 1. And then for our course 1, the only prerequisite is 2. And then for our course 2, the only prerequisite is 0. And there are two ways you can store this. The first is by just using an array. So for example, index 0 would give us our prerequisites of just 1. Index 1 would give us our prerequisite of 2, and so on. Or you could just use a hash map, which is a little more clearer in my opinion. So for example, you'll have our key, and you'll have the value, and you're going to iterate through every key and the values, and we're going to treat them as node and neighbors. For example, if we do DFS of 0, then we're going to visit all the neighbors in the value array, and we're going to have DFS of 1. So now for DFS of 1, we look at our key for 1 and see that the neighbor is 2. So we're going to make another call for DFS 2. And then we do the same thing. We look at 2, and then we make the DFS call for all the neighbors. So we're going to make another call for DFS of 0. And then at this point, we would just continue in a infinite loop, because now we're going to have to call DFS for 0 and start it all over again. And there's no exiting. So now that we know how to create and traverse the graph, let's get into the solution of how to detect the cycle. So what we're going to do is just a slightly modified depth first search. So I'm going to write the steps down here. So first we want to do a depth first search. And then while we're doing the depth first search, we want to mark the nodes as visited. So mark nodes. And normally we only mark the nodes as visited or not visited. But for this example here, we have to keep track of whether we have a cycle or not. So we're also going to add a third option, and we're going to call it visiting. So here are the three options we can label the nodes as. So for example, if we're starting out and we haven't visited any nodes, they're all going to be initialized to 0. So what we're going to do is have an array for each node. So we're going to have an array for 0, 1, and 2. And this array is initially all zeros. So let's say we start at node 0 here. Well, currently 0 is not visited, so we can mark it as visiting for now. And then we go to its neighbors. And now we go to 1. So we see that 1 is also not visited yet, so we can just mark it as visiting still, because we haven't completed the DFS call. And then we go to 1's neighbors, which is 2. And same thing for 2, we mark it as visiting. So now from 2, we visit its neighbors, and we see that the neighbor is 0, so we're going to do a DFS call for that. But once we get to 0 again, we see that we're still in the process of visiting the node, meaning that we haven't completed the DFS call stack. So basically, if we're still visiting a node from the same call stack, then that means we have an infinite loop, meaning we can't complete all the courses, and we would return false here. Okay, well let's say it wasn't an infinite loop, and that this prerequisite was gone. Well, from 2 here, we could just mark it as visited, because we already visited all the neighbors, which is none of them. So we can just mark this as 1, and then we can go back to our DFS call for 1, and we're done visiting its neighbors. So we also turn this into a 1. And then we go back to 0, and we also turn that into a 1. And then at the end, since we have no cycles detected, then we just return true. Our time complexity for this algorithm is going to be O of n plus m. And what n means is the number of nodes, and m is the number of edges. So for example, we have our node 0, 1, and 2. And we also have all of these edges here that we have to visit, meaning that we have to go through every node, and we have to go through all of its neighbors. So let's say we would have 0 and then 1 and 2. So that's what O of n plus m means. For space, it's only O of n because we only have a hash map and this array here, which are both of size n. Meaning that we're only iterating through the number of courses. So now let's get into the code. To start, we have to start by creating our hash map, and I'm just going to call it graph map. And what this is going to contain is our course mapped to our prerequisites. So initially, it's just going to be our course number initialized to no prerequisites, and we're going to do this for I in range of num courses. So now every single course is in our hash map with no prerequisites, and now we want to populate each course with its prerequisites. So we're going to do for course and each prerequisite in our prerequisites array. We're going to do graph map at the key course, and we're going to append our prerequisite. So now every single course and its prerequisites are mapped together, and that'll help us traverse the graph. Now we want to have our visited set. So we're going to have our visit set, and we're going to initialize that to 0 for every single course. And then from here, we just want to iterate through every course in our num courses. And we're going to check if it is a cycle for this current course, then we're going to return false, because this means we can't take every single course since there is a cycle. Otherwise, at the end, we just return true. And now we have to create our isCycle function. So we're just going to do it above here so we can reuse our graph map and visit set. So I'm going to call it isCycle, and our input is going to be just the course number we're at. And what we're going to do is first set our course to visiting. So we're going to update our visit set at the key course and set it equal to 2, because like I said, that means we are currently visiting it. And then now we want to iterate through every single prerequisite for this course. So for each prerequisite in our graph map at our key course, we want to do some checks. So first we want to check if we're in a loop. And the way we do that is, if we're in a loop, then that means we're already visiting a previous node that we're already visiting. In other words, if visit set for our prerequisite is equal to 2, then that means we're visiting a node again, and we just return true. The other check we want to do is check if visit set at our prerequisite is equal to 0, meaning that we haven't visited it. Then we want to do our isCycle from there because we're visiting its neighbors. And then if this returns true, then we also want to return true here because that means we created a loop. If we get past these two, then that means we can just mark our visit set at our course equal to 1 since we found no loops, and we can just return false here since it's not a cycle. And then this should just work. As you can see, this code is pretty efficient, and now I'll go through the code manually. To start, I've set up this graph here that has an infinite loop at 1 and 2, and I'm not going to be writing out each and every individual step because that would just take way too long. So it's going to be more of a conceptual overview. So to start, we want to initialize our graph map, which I've already done here. Our 0 is mapped to 1, 1 is mapped to 2, and 2 is mapped to 1, like you can see in the graph here. And then our visit set is initialized to 0 for every single node in num courses. And then we want to go through every single course available and check if it's a cycle. So first we're going to go through course 0 because that's the first course. So currently we are at course 0. So first we want to change our visited array to be equal to 2 at index 0 because we are currently visiting that. So let's do that. And now we go through every neighbor for the 0. So as you can see, the only neighbor is 1. So we're going to do our pre is 1. And now we check. If we're currently visiting 1, then we return true. And as you can see, we're not currently visiting 1 because it's equal to 0. So now we go to the next condition and we check. If we haven't visited this node and it is a cycle, so now we're doing recursion, then return true. So now we're doing is cycle for 1. And now we set visit set at 1 equal to 2. So now we're currently visiting node 1. And now we check every neighbor for 1, which is only 2. So let me just update this. And now we check. Are we currently visiting this node? Well, no, because it's 0. So now we go to the next condition. And we do, if we haven't visited this current node and it is a cycle, then we return true. So now we're going to check if 2 gives us a cycle. So let's see. Now our course is 2. So now we set our course to 2. So now this array says we're visiting 2. And now we check every neighbor for 2. So our only neighbor for 2 is 1, as you can see in the graph here. And now we check. Are we visiting node 1 in our current recursion stack? Well, we can see that here we have a 2. So that means we are currently visiting it. So we would return true here. Now that we have that, we can pop back to 1 and see that it is a cycle. So we also return true here. And then we pop back up to 0. And for 0, we're visiting the neighbor. So we would return true here again. And then once that's done, we return true for this isCycle function call here, which tells us to return a false, which is correct. There is an infinite loop here, which means we can't complete all the courses. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.